In this unit, we're going to be studying number sense. In this lesson, we're going to look at rational numbers. Okay, hi everybody. In this lesson, we're going to look at rational numbers, or as most people know them, fractions. Okay, we're going to start working with fractions here. Okay, or pieces of a whole. That's really what we're doing here. Now, we write these things as A over B. And remember that implies division, right? This is the value of A divided by B, or divided into B pieces, where B is not 0. Okay, if you let B go to 0, then that becomes undefined. If you were to try to do that in your calculator, you'll see that you'll get an error. Okay, so we're taking a number, we're dividing it by another number here. Okay, we're taking this amount and dividing it into this many sets, this many groups. Okay. Now, actually, it's interesting to note here too. If you take a look at it, if you think about your division symbol, the division symbol is again a bar, just like this one, with a dot where the numerator and denominator are. Okay, dot for the numerator, dot for the denominator. So it's basically sort of the same symbol. The implication is there's a similar symbol here. Remember, we call the top number there, the one on the top there, the numerator, and the bottom one is the denominator. Okay, the numerator is kind of the amount that we start with, and then the denominator, right, is the number of sets we're dividing it into. At least this is one way of thinking about it. Okay, the number of sets we're dividing it into. So, for example, let's take a quick look here. We got three different types here. We've got a proper fraction, an improper fraction, and a mixed fraction. So here's a proper fraction. Now, the negative there is just there to give it a sign. Okay, it could be a positive fraction. It could be a negative fraction. Basically, that negative just tells us what side of 0 we're on. Okay, if you're looking at the number line, so the negative tells us we are to the left of the 0. Now, 3/4. Now, it's important. It helps to think about it like that. Okay, we know that this is division. We know that this is the number 3 divided by 4, and we're asking, like, what do we get when we do that? And that's true. That's totally true. And you could get a decimal value here. You could get that 3 divided by 4 is 0.75, and that's true. But there is another way of looking at it. And it comes through in how you say it. I've got 3/4. Well, what's a quarter? A quarter is when we take a shape like this circle here and divide it into 4. I divide it into 4 pieces. The numerator then tells us how many of those we have. I have 3 of them. 1, 2, 3. So when I said here that it was the number that you start with, that is one way of thinking about it. And that's the way of thinking of it that leads you to getting like 0.75 as your answer. Or the numerator is the number of the pieces you get dividing 1 by the denominator. That's what I just did here. I took that one circle, divided it into quarters. So I've got, divided into 4, I should say, and I get these quarters, and then I've got 3 of them. So my numerator here is going to be, and let's say -3. The negative can really kind of go wherever I want it to go, but we'll put it on the numerator. That's typically what we do. The denominator is 4. Now, when it asks for the definition, we're asking for the definition of a proper fraction here. This is a proper fraction is a fraction in which the numerator is less than the denominator. Now, that means that its value is going to be, okay, so, and we'll say it like this, the value, or actually let's say the decimal value, that's probably a better way to say it, the decimal value is between -1 and 1. Okay, so we're dealing with a fraction that is, strictly speaking, a part of a whole. It's less than a whole, the whole being equal to 1, whether that be a positive one or a negative one. Now over here, we've got the improper fraction. Now here, once again, I'm dividing into quarters. I'm dividing the whole into quarters. Each of my wholes here, I divide into quarter here. But I've now got 7 of them. So 1, 2, 3, 4, 5, 6, 7. So my numerator is 7, my denominator is 4 here. So what is the definition of an improper fraction? Well, it's a fraction where the numerator is larger than the denominator. Okay, so the decimal value, oops, I keep doing that, decimal value. Okay, well, there's a few things that we could say about that. The decimal value is either, here we go, it's either going to be greater than 1 or less than -1. Now over here, we take a look at a mixed fraction. Now a mixed fraction is where we split this thing up here. Now bear in mind this is division. Okay? When we write it as a fraction like that, when we write it as an improper fraction, it's a division statement. Okay, that's what it is. I'm dividing 7 by 4. Okay? Here, what I'm doing is I'm writing this out as, I'm taking my improper fraction and I'm writing this out as my quotient and remainder when I do the division. So, for example, if I was to take 7 and divide it by 4, well, I can divide, there's one whole there. There's one whole, and then I've got a fraction of a whole left over. I've got 3 left over as a remainder, 3 of these quarters as a remainder there. So this is my mixed fraction. When I divide 7 by 4, I get 1 as my quotient with a remainder of 3. Okay, so 3.5 means I've got 3 wholes, and then in addition to that, I'm dividing one of the wholes by 2, and I've got one of those pieces. Now, in this particular case here, it's not quite the same. It's not quite the same when I ask for the numerator and denominator, because technically speaking here, my numerator is 1, my denominator is 2, but I have some wholes there as well. Okay, I've got some whole values here. So the definition of a mixed fraction here, it's a fraction where I guess we're saying where the division statement, in other words, where we've done the division, where the quotient and remainder are visible. Okay? So the whole number that we use is the quotient, and the fraction is proper. Okay, and the fraction is proper. So if we've done this completely, if we've written this out the way we're supposed to, okay, that 3 there represents the quotient of some sort of division statement, and then I had 1 piece out of 2 parts left over. Okay, so let's take a quick look at some conversions. Okay, and then we'll do some more examples here. So for example, converting fractions here. So I'm going to convert this into a different form. Now, we're going to say this in just a little bit here. What I'm not going to do is convert a proper fraction into an improper or an improper into a proper. When we convert fractions, we are not changing the value. That's really important. We're just changing how it looks. That's it. That's it. I'm not changing the number here. It's still going to be the same number. If I was to evaluate the decimal value of this, that would be the same. Okay? So when I take 25, this is 25 over 3. Okay? I'm not going to change the decimal value of this. But what we are going to do is change the way it looks here. So divide the numerator by the denominator. So 25 divided by 3. Okay? That is going to give us 8 with a remainder of 1. So 8 times 3 is 24, plus 1 gets us that 25. So that means 25 over 3 is going to be 8 wholes with one of those third-sized pieces left over. 8 and 1/3. Now, to go the other way, if we wanted to convert from a mixed fraction to an improper fraction, and that's typically how this works. This really won't get converted into a proper fraction. Proper fraction is too small for this. There are no whole values there. What we would do here is we got to go the other way here. So just like over here, I took and divided 25 by that 3 to get the 8, the quotient. I'm going to multiply to go backwards here. So I'm going to do 4 times that denominator. Okay, so 4 times 3 is going to be 12 plus that remainder, that little bit left over. I'm going to go 12 plus 2 over 3 here. So this gets me 4 2/3 is the same as, when I add those together, 14/3. 4 wholes. How big are the holes? Well, the holes are broken into 3 pieces. So 4 of those thirds, so 4 wholes multiplied by those pieces that are 1/3 of that gives me 12 of those pieces, and then I had 2 left over. So this is like going 1, 2, 3, 4, and then I took that last one and I broke it up into 3 pieces. So I've got, if each one of those was broken up into 3, I'd have 4, 8, 12. Wait a minute. Oh my gosh. Why am I adding by 4s? That's 3, 6, 9, 12. I'm so sorry. That's embarrassing. 3, 6, 9, 12, and then 2 left over. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 thirds. Okay. Now, little note here. We're not going to be converting proper fractions to improper fractions because they're different values. Okay. This is a value smaller than 1. This is going to be a value, for example, greater than 1. And I can't convert those into each other. But lastly, before we start to look at some examples here, equivalent fractions are fractions that have the same value when you reduce. In other words, when you get rid of common factors that are in the numerator and denominator. Okay? Because sometimes there are multiple ways that you can write the exact same relationship. We want to default to the smaller value. So for example, 50 over 100. Okay, if I've got 50 hundredths, well, that's the same as I could divide both of those by that 10. This 50 is like saying 5 times 10, and 100 is 10 times 10. Well, I can divide. I can do this little division here. 10 divided by 10 goes away. It becomes 1 multiplied by 5/10. And 5/10, okay, 10 is twice as big as 5. So what we're saying is the denominator is twice as big as the numerator. So I could write that as 1 over 2. And this is the best way to write that. It makes sense to me. In my head, I have a little bit more difficulty dealing with these larger numbers, but 1 out of 2, okay, or half of an object, that makes way more sense to me. It's quite clear. Anyway, let's take a look at some examples now. So here we go. So the first question we're going to look at here is reduce the following fractions if possible. In other words, we want to take these fractions here and write them in terms of an equivalent fraction that's much smaller in terms of the numbers. Now, the more comfortable you are with your multiplication tables and whatnot, the easier this is. So for example, when I look at 12 and 52 here, well, right now 12 out of 52, okay, that maybe doesn't communicate to me super clearly what the relationship is. But, I mean, for example, I know that 12 is 2 times 6. And I know that 52 is even as well, so I know it's going to be 2 times 26. Now, I have a little bit of freedom here. This is 2 times 6 divided by 2 times 26. Well, I've got a little bit of freedom here. I can divide out the 2 by the 2 here. 2 divided by 2 is 1, and 1 times 6 over 26 is 6 over 26. But these are also both even. That's going to be 2 times 3 This is going to be 2 times 13. Just like I did over here where I did that division, because I'm allowed to, I can divide this 2 by this 2 again to get 1, multiplied by 3 over 13, and so my answer is 3/13. Now, 12 over 52, maybe I don't have a really good sense of what part of a whole that is, but I have a much better idea of what 3/13 looks like. Okay, because those numbers are smaller, it's very easy for me to get my head wrapped around it. Over here, 24/28. Again, I'm looking for something that's common to both. Now, in this case right here, I can see pretty quickly that the answer is going to be 4. I know that 4 times 6 is 24, and 4 times 7 is 28. Now, again, because I'm allowed to do this, I can do this little bit of division here. 4 divided by 4 is 1, and 1 times 6/7 is 6/7. And that's as far as I can go because 7 is prime. Okay, I can't break 7 down into any other factors here, so I know there's going to be nothing shared between the numerator and denominator. So that's as far as I go. And 6/7 is much clearer to me than 24/28. 16/24. Again, just a quick look at this thing, and I can tell that 4 is, again, the common factor here. Or I shouldn't say the common factor. I should say it's a common factor. So 4 times 4 is 16. 4 times 6 is 24. Again, the 4's will cancel, and I'm left with 4 over 6. But before I go on to the next question, I look at that and think, well, wait a minute. I can do more than that. So clearly 4 wasn't the largest number here, because 4 up here is even, well, so is 6, which means there's a common factor of 2 that I can cut out there, and now I know that this is 2/3. So maybe when I look at 16 over 24, I mean, I don't exactly know what that amount is, but 2/3 is much clearer to me. I understand 2/3. I can see that. I can visualize that, right? You know, I got my 3 fingers here, and then I've got 2 of them, right? 2 out of the 3. 50 and 75. Well, 50 is even, but 75 isn't. So I can't pull out the 2's like I have been in the last little bit here. But this one ends in a 0, this one ends in a 5. So I can pull out a 5 out of both of those. Okay, and 75 divided by 5, maybe that's not 100% clear to you right away here, but it's going to be 15. And then the 5 divided by 5, and then I've got 10 over 15. And again, these are both divisible by 5. Sorry, I'll do it like this. 5 multiplied by 2, 5 multiplied by 3, 5's cancel, and again you've got 2/3. Now, and this is kind of what I was talking about before here. Like, did you know off the top of your head that 16 over 24 and 50 over 75 were actually the same thing? Probably not. But they both reduce down to the same small fraction. It's when I've got it reduced that that relationship becomes clear. Over here, looking at this one right here, the negative, there's not much I can do with that negative, so it's just going to stay there. But between 42 and 49, there is a common 7 to both of those. And then the 7's are going to cancel. I'm left with negative 6 over 7. And then look at that. Now, granted, this one is negative, but that really only tells us what side of the 0 that's on. But look at the values. They're the same here. So, I mean, did you know right off the top of your head that 24 out of 28 was the same as 42 out of 49? Probably not. Now, this one right here, there is a common factor to numerator and denominator. It's going to be 2. So this is going to be 2 times 4 over 2 times 3. The 2's will cancel. I'm left with 4/3. However, I probably want to go a little bit further here. Because this is an improper fraction, because my numerator is larger than my denominator, I'm going to do the division. So 4 divided by 3 is 1. Okay, and then there's 1/3 left over. Okay, there's a remainder of 1 left over. Good. Now here, let's determine whether these are equivalent fractions. Now there are a couple of ways that you can do this. Okay, there are a couple of ways you can do this. I'm going to do this one way, and then I'm going to show you the shortcut method with this, and then we're going to use that over here. Are these equivalent? Well, the way that we're supposed to do this is by reducing both sides as far as you can so that you can get the same number here. And then I would know, for example, that 16 over 24 was the same as 50 over 75. So here, 1/12 is about as good as it's going to get. So I'm going to reduce this 5 over 55, and that's 5 over 5 times 11. Now, is that equal to 1/12? I don't know. But there's a common 5 there that cancels, and so when that's gone, I get 1 over 11. Because remember, 5 divided by 5 is 1, multiplied by 1 over 11. Is that the same as 1 over 12? No. No, it's not. Okay? Now, at this point in time, I suspect you're probably familiar with this little operation here, though, as well. One of the things that we can do here is, because I've got a proportion, which is just fraction equal to fraction, if I take the numerator here and multiply it by the denominator, that should be the same as this denominator multiplied by this numerator. We call that cross multiplication, right? So 5 times 12 is 60. Is that the same as 55 times 1, or just 55? The answer is no, it's not. So as a result, those are not equivalent. Now here, I could do the same thing. I could reduce numerator and denominator, okay, and see if I get the same fractions on both sides. But let's try it the other way. Is 16 times 192, is that the same as 48 multiplied by 64? Now I got to use my calculator over here. So 16 times 192, 3072. Now I don't care if that's a big number. I don't care, because the calculator's doing the work here. All I care about is it the same as 48 multiplied by 64? And it is. So in which case, yes, they are equivalent. So here, no, they're not. Here, yes, they are. Now, I still don't know what it's equivalent to. I don't know what the reduced value is, but I do know that they would be the same. All right, now we're going to do just a handful of questions here where we're going to convert from mixed to improper fractions, or vice versa here. So, 17/5. I am dividing 17 into groups of 5 here. Now, there is a number that is nicely divisible by 5 that is 2 less than 17. Okay, 15. 15 divided by 5 is 3. And then I have those 2 left over. Just like over here. Now over here with the negative, I'm just going to drop the negative out front. 23 is not divisible by 7. But if I take 2 off of the 7, if I take 2 away from the 23, if I take 2 away from the 23, 21 is. 21, whoa. No, that's not what I meant to write. 21 divided by 7 is 3. So I got 3 wholes with 2/7 left over. Okay, and I'm going to show you another way of handling that in just a moment here with one of the last questions. I'll show you another way of writing that might help here. This one is a little bit easier. I already know that if it's a mixed fraction, if it's a mixed fraction going to an improper fraction, my denominator will be the same. So like in each of the following here, I know what my denominators are going to be. The question is, what's the numerator? And you do it by going whole, multiplied by denominator, add the numerator. So 2 times 8 plus 1. 2 times 8 is 16, plus 1 is 17, so 17/8. 5 times 3 plus 2. 5 times 3 is 17, plus 2. 5 times 3 is 15, plus 2 is 17. Okay? And so I get 17/3. Here, that negative is just going to sit out front. Don't worry about the negative. That just tells us what side of the 0 we're on. 4 times 2 plus 1. Well, 4 times 2 is 8, plus 1 is 9. Now I'm going to do this one again. I'm going to show you maybe another way of thinking this thing through here. The negative is simply going to make the answer negative. Okay, that's fine here. So we'll do it like this. I'm going to take that 99, and I'm trying to think, is there a number is there a number that's a little bit less than 99 that is in fact divisible by 5? And the answer is yes, it's 95. But that means I took 4 away. Okay, so 95 plus 4 over 5. Now what I do is I do this division. But I do it in parts here. Both of these numbers are going to get divided by 5. That's kind of how that works. It's what we call distributes here. So 95 divided by 5 is going to be 19. And then I have the 4/5. Now, I don't know what that looks like as a decimal. I'm just going to write 4 divided by 5 just to tell me that there was a little bit of division left over that still didn't get done. And there we go. That's how you would write that answer. Okay, the next thing we want to look at here is adding and subtracting fractions. Okay, so, and I'm just going to basically read through what was written out here because it actually covers everything, although me reading is maybe not very exciting, but regardless. So fractions have to have the same denominator in order to add or subtract. Okay, and you're going to see that that actually plays itself out quite clearly as long as you speak the fractions properly. So you've probably already heard, you can't add apples and oranges. And yeah, and I understand the sentiment behind that, but perhaps the meaning gets lost to people. It's like saying, if I can't add 5 apples and 3 oranges, what do I get? Well, you could answer that, well, you got 8 pieces of fruit. Okay, sure. But notice that you changed the object when you did that addition. Okay? It's much easier to say 5 apples plus, let's say, 3 apples is 8 apples. Okay? Where this little thing that the identifier, I don't have to fiddle with it. If it's the same identifier, it's like 2 cats plus 3 cats is 5 cats. 2 cats plus 3 cars is 5 objects. 5 things, right? All of a sudden, I can't use the same identifier, okay? So we really do want the same denominator. And when you hear me talk through some of these examples, I'm hoping that you'll hear it when I do it, how it relates back to this apples and oranges sort of example. So it's easier to add and subtract with mixed fractions when they are written in improper format. In fact, I really encourage you to do that. It's so much easier just to convert these to mixed fractions. Then you're not borrowing and carrying in the same way. It's a lot more straightforward. So what you got to do here is, first of all, if you got like fractions, in other words, the denominators are already the same, then all you got to do is add or subtract the numerators. That's it. Okay? And again, when you talk through the work, that makes sense. You'll actually hear it. You'll hear it as you go through exactly what it is you have to do. The issue comes when we have different denominators. So we just spent a little bit of time looking at equivalent fractions, but most of the time when we're dealing with equivalent fractions, we're making things smaller. But in this case here, you might actually want to get a fraction where the numbers are a little bit bigger. So what we're looking for is the smallest number, the lowest common multiple of the numbers in the denominator. And then we're going to rewrite the fractions with that new lowest common multiple as the denominator. And once the denominators are the same, then we can simply add or subtract the numerators. But at the end here, you probably want to write your answer in reduced form. Okay, so you might have to make the numbers a little bit more complicated to begin with, but at the end you're going to reduce things just to clean it up. Okay, let's take a look at some examples. Okay, let's do some work with fractions here. So here I'm adding 5/6 and 3/6. Now, I know that fractions can be really confusing for people, but a lot of that can be kind of sidestepped by just speaking this properly here. When people look at this and see it as 5 divided by 6 plus 3 divided by 6, yeah, well that seems a little complicated. But don't see it like that. Say it the way it's supposed to be said here. This is 5/6 plus 3/6. Now, granted, maybe you don't know instinctively what a sixth looks like. But if you've got 5 of them here and 3 of them here, altogether that's 8 sixths. Okay, it's like 5 apples plus 3 apples is 8 apples. 5 sixths plus 3 sixths is 8 sixths. And I know I keep doing that, but I'm hoping that kind of makes sense to you. Then, once I'm done that, now I'm going to try to reduce it here. So 8 is 2 times 4, 6 is 2 times 3, and then the 2 divided by 2 is going to be 1. And so I'm left with 4/3. And then maybe I go one step further and I say, well, 4 divided by 3 is like 1 with a remainder of 1. So 1 and 1/3. Okay, good. Now, over here, I've got 2/5 minus 1/2. Okay. Now I'm to the apples and oranges thing. Okay, I've got 2/5 minus 1/2. Well, that's not the same thing. Okay, I cannot clearly see what the relationship is here. Okay, so what I got to do is I got to focus my attention on those denominators there. 5 and 2. So what is the smallest number that both of those numbers are a factor of? Now, in this particular case here, it doesn't take us long. 5 doesn't work, but the next multiple of 5 is 10. No, and 10 is a multiple of 2. So what I can do here is I'm going to try to make this over 10 minus something over 10. Now, in order to turn 5 into 10, I just have to multiply by 2. And you've probably heard this a bunch of different times here, that if you multiply the denominator by some value, you've got to multiply the numerator by it at the same time. So just like over here, I canceled out the 2's to get this to 4/3. I could have gone upwards and multiplied both by 2 to take us up to 8 sixths. It's the same thing. So 2 times 2 is 4, 2 times 5 is 10. Here, I have to multiply the denominator by 5 to turn it into 10, which means I got to multiply the numerator by 5. Okay? Again, it's the same thing. It's just me going backwards here, just picking a different number to multiply by numerator denominator. And 5 times 1 is 5. Now, 4/10 minus 5/10. Okay, that's a lot easier. I know I'm going to have a certain number of tenths. But how many? 4 minus 5, okay, that's going to be -1. And there we go, -1/10. And again, that simply tells me that this number is on the other side of 0. Right here, 2/5 plus 1/6. 2/5 plus 1/6. Okay, well, I'm not adding the same objects, the same type of fraction here. So now I got to look at this again. Let's look at multiples of 5. Well, 5 doesn't work. 10 doesn't work. 15, no. 20, no. 25, no. But 30, the next one is a multiple of 6. But none of the ones before that were multiples of 6. So 30 works. So I'm going to turn both of these into fractions out of 30. So I have to multiply numerator and denominator here by 6. So 6 times 5 is 30. 6 times 2 is 12. Just got to do the same thing, numerator and denominator. And then over here I multiply by 5, multiply by 5. And 5 times 1 is just going to be 5. So here we go. Now I've got the same thing. 12 30ths plus 5 30ths is 17 30ths. Good. Now I take a quick look at that and think, okay, well, can I simplify that? Because that's what I would like to do if possible. But the answer is no. 17 is a prime number. It doesn't have any factors that it can share in common. And 17 is not itself a factor of 30. So I'm kind of done. There's nothing I can do to compare those two. So that's as good as it's going to get. Down here, 5/9 plus 7/10. Now, it's probably not going to take you long to realize that, you know what, one of the things that I can do here is simply multiply the two denominators together. And in this case here, that is what you're going to end up doing here. The denominator is going to become 90ths. which means over here I had to multiply numerator and denominator by 10. So it's going to be 50 90ths. And here I had to multiply numerator and denominator by 9. It's going to give me 63 90ths. Okay? So now I know that 50 90ths plus 63 90ths, okay, is going to equal 113 90ths. Okay? And so now that's an improper fraction. They don't really have any common factors there, though. Okay, between 113 and 90, but I can write this as a mixed fraction. 113 divided by 90 is going to be 1, with 23 90ths left over. And then I'm going to take a look at 23 and 90. Are there any factors that are common? And the answer is no. 23 is a prime number. And it's not a factor of 90, so that's as good as it's going to get. So, just really quickly, notice in these last three examples here, what did I end up doing to get the common denominator? Well, I multiplied the denominators together. I multiplied the denominators together. I multiplied the denominators together. Will that always work? Yeah, that'll always work. But it's not always the most efficient way to do that. Take a look at this problem. 5/8 plus 1/2. Okay, again, I'm not adding the same thing. I'm adding 5 apples plus 1 orange. Okay, it's not the same thing. It's not a clear-cut way to add those together. But is 8 a multiple of 2? And the answer is yes. So I can actually take that 1/2 and I can write that as a fraction with a denominator of 8. I just have to multiply numerator and denominator here by 4. And that's going to give me 4/8. Now, that means my answer is going to be over 8, and 5 plus 4 is going to be 9. And so 9 and 8 don't have any common factors, but I can convert that into a mixed fraction. 9 divided by 8 is 1, with 1 left over. Now, could I have gotten the same place by multiplying the two denominators together? Yes. And if you want to see what that would look like, this is what would happen here. 5/8 would have become, if you multiply denominator and numerator by 2, would become 10 16ths. And here I would multiply denominator and numerator by 8, so it would become 8 16ths, which is going to be 18 16ths. There's a common factor of 2 to both of those, so you cancel those out, and actually takes us right back up here to this step, and then I wrote it as a mixed fraction. So yeah, I could, but it introduces a little bit more work. Okay? Now finally here, 1/8 minus 1/7, and again, 1 apple minus 1 orange. Okay, well, it doesn't work. Okay, I'm talking about very different things here, but I can make them the same. In this case, though, again, unlike this one here, the way I'm going to do this is to simply multiply those together. Okay, 7 is a prime number, so it's a little bit unforgiving in terms of trying to find something that's a little bit smaller here. So I'm going to multiply by 7, multiply by 7. This will be multiplied by 8, multiplied by 8. And so we are going to get 7 56ths minus 8 56ths. So I know that I'm going to get a certain number of 56ths. Well, how many? 7 minus 8 is negative 1. So it's 1/56th. But if I think about this as being placed on the number line, it'll be just a little bit to the left of the 0 on the number line. And now just a few more dealing with some improper fractions here. So like we were saying before, it would probably be easier if we just converted these to improper fractions first. So something over 4 plus something over 5. So 1 times 4 is 5. So, wow. 1 times 4 is 4 plus 1 is 5. Sorry, I was anticipating where that was going. 2 times 5 is 10 plus 2 is 12. Now, between 4 and 5, well, 4 isn't a multiple of 5. 5 is not a multiple of 4. There's no shared factors there, so the smallest number that we're going to get here is going to be 20. But it means I have to multiply a numerator and denominator here by 5, and I got to multiply a numerator and denominator here by 4. So 5 times 5 is 25, and then 12 times 4 is going to be 48. So 25 plus 48, put those together, I am getting 73 twentieths. Okay, 73 twentieths. Well, 73 is not even, 20 is. 20 is also multiple of 5, but 73 isn't. There really isn't a common factor there. Okay? But we can divide that by 20. We can convert this into a mixed fraction here. And we're going to get, what are we going to get here? We're going to get 3. Okay? 3 times 20 is going to be 60. That's as close as we're going to get to 73, but that leaves us with 13 left over. So 3 and 13 twentieths. Now this one right here, I've got a negative here and a negative here. Oh, okay. Well, let's not worry about that. It's going to be negative something over 7 minus something over 5. I'll deal with the negatives later. Let's convert these to improper fractions first. So 2 times 7 is 14, plus 3 is 17. 1 times 5 is 5, plus 2 is 7. Okay, well, I got a negative there. I got to get a negative there. Just like with the previous question here, 7 and 5 don't really have anything in common per se. So what we're going to do is we're just really going to just multiply them together. So I'm going to multiply this fraction, numerator and denominator, by 5, and that's going to get me 85 over 35. And then I'm going to multiply both numerator and denominator here by 7, and that's going to get me 49 over 35. Okay, well, I know my answer is going to be a 35th. However many 35ths. Well, how many 35ths is that? Well, what is negative 85 minus 49? Negative 85 minus 49. You got to make sure that you throw that negative in there. So what we're going to do here is we are going to get negative 134. Okay. Now, what we're going to do is we're going to convert that. Now, how many times can we divide that? How many times can we grab 35 objects out of 134? Well, I believe the answer is going to be 3. Now, because of that negative is going to sit out front there, and we're going to have 3 out front there. So now 3 times 35 is 105, which leaves us with 29 left over as my remainder. So negative 3 and 29 35ths. Good. And we'll do one more. In this case here, the first fraction is already an improper fraction, so we're good. I want to convert this next one to an improper fraction out of 3. So 1 times 3 is 3, plus 2 is 5. 7 and 3. There's really going to be nothing that I'm going to get to sooner than multiplying them together. So we're going to get fractions out of 21. So 24 times 3 will be 72. 5 times 7 is 35. So 72 plus 35, this is going to be, and remember, this is 72 21sts plus 35 21sts. That's going to be 107 21sts. Okay. Now, well, let's convert that to a mixed fraction. Well, 107 divided by 21 is going to give us, let's check it, it's going to be 5. Question is, how many 21s do I have left over? So 5 times 21, or I should say 21st here, 5 times 21 was 105. So we get really darn close here. There's just 2 left over. So it's going to be 5 and 2 21sts. And there you go. So I hope that gives you a little bit more confidence working with proper fractions, improper fractions, mixed fractions, and the operations that we do with them.